Ed White floated free above the Pacific on June 3, 1965, tethered to a spacecraft with a hatch that, 20 minutes later, refused to lock shut. He was the first American to leave a capsule in orbit. His command pilot, James McDivitt, was alone inside Gemini 4 with a door that wouldn't seal, a re-entry deadline closing in, and no way to call Houston for a fix. If that hatch stayed open, the capsule would lose pressure the moment they hit the atmosphere. 2 men, 200 kilometers up, and a mechanism never fully tested for what they were about to ask of it. Gemini 4 was NASA's second crewed flight in the program, built to prove America could handle rendezvous, long-duration flight, and work outside a spacecraft before Apollo tried the moon. The Soviets had already put Alexei Leonov outside Voskhod 2 in March of that year, so the pressure to match that milestone was immediate. McDivitt commanded the mission. White would attempt the spacewalk. Their hatch was a single outward opening door, sealed by a hand-cranked mechanism of gears and latching pins that had been tested on the ground, but never opened and closed in the vacuum of actual orbit. That gap between ground testing and orbital reality is where this story lives. The plan called for White to open the hatch on the 3rd orbit, step into open space tethered by a 25-foot umbilical line carrying oxygen and communications, and maneuver using a handheld gas gun that fired small bursts of compressed oxygen to push him around. Getting the hatch open took longer than expected. The mechanism stuck part way, and McDivitt had to help force it before it would swing clear. Neither man mentioned it much at the time. They had a spacewalk to run, and the clock on White's suit oxygen was already ticking. White pushed off. For the next stretch of the mission, he drifted and spun above the curve of the Earth, using the zip gun until its propellant ran low, then hauling himself hand over hand along the tether. He described the sensation as one of the most vivid of his life, and the footage NASA got back showed something the American public had never seen live: a man detached from his machine, held only by a line, moving against a black sky. It played on television. It made the cover of magazines. For those 20-some minutes, everything worked exactly as designed. Then came the order to come back in. That's the part almost nobody remembers. Getting White back through the hatch and sealed inside took real effort. His suit had stiffened in vacuum, his gloves fought him, and by the time McDivitt hauled the door shut behind him, both men were breathing hard inside suits already running warm. That was expected. Spacewalks are physical. What happened next was not expected at all. The hatch had to be relocked using the same hand-cranked ratchet mechanism that had stuck on the way out. This time it wouldn't catch. McDivitt worked the crank. The gears turned, but the locking pins wouldn't seat into position. He tried again. Nothing. Inside 2 pressurized suits, in a cabin the size of a car's front seats, the 2 men now faced a problem that had no obvious backup plan, because Gemini's hatch design didn't include one. Here's what made it dangerous rather than merely inconvenient. Gemini re-entered the atmosphere at roughly 17,000 miles an hour, protected by a heat shield built to handle temperatures that would vaporize aluminum. That shield only worked if the cabin held pressure. An unlatched hatch wouldn't just let air escape. Under aerodynamic loads during descent, it could rip free entirely, and NASA had no procedure for a Gemini crew surviving re-entry with an open door. This was not a scenario built into the flight plan. It was the scenario nobody wanted to plan for. McDivitt kept working the mechanism by feel, since he couldn't fully see the latch engage from his seat. White, still catching his breath from the EVA, helped brace and align the door while McDivitt forced the gear train through its cycle. Reports from the mission afterward described the effort as exhausting, enough that McDivitt's heart rate, already elevated from the spacewalk support work, climbed further during the minutes spent fighting the latch. Neither astronaut radioed panic. Gemini crews trained to solve problems quietly and keep talking to the ground in flat, procedural language. And that's exactly what they did. Even as the stakes climbed with every failed attempt, what finally worked was persistence rather than a fix. After repeated cycling of the ratchet, the gears caught, the pins seated, and the hatch locked. McDivitt confirmed it by feel and by watching the mechanism's indicator. There was no dramatic announcement, just a status update relayed to mission control that the hatch was secure. The rest of the flight, nearly 4 more days orbiting the Earth, testing rendezvous techniques with the spent booster stage, running out the clock on what was then America's longest crewed spaceflight, proceeded as if that half-hour of quiet crisis had never happened. Engineers on the ground didn't have that luxury. Once Gemini 4 splashed down in the Atlantic and the crew was recovered by the carrier Wasp, the hatch mechanism became a subject of real scrutiny. The working theory that emerged, and one that would recur across later Gemini EVA missions, involved the behavior of metal parts in vacuum. On Earth, metal surfaces are protected by thin films of oxide and contamination that keep them from bonding to each other under pressure. In the hard vacuum of space, some of those protective layers can wear away during repeated contact, and bare metal on metal surfaces under load can gall or partially fuse, a phenomenon engineers sometimes call cold welding. A ratchet mechanism cycled once on the ground and once in orbit was exactly the kind of system where that risk could show up unpredictably, and investigators looking at Gemini's hatch hardware treated this as a plausible contributor, even though pinning an exact cause to a single mechanical event from telemetry and crew reports alone was difficult. Whatever the precise mechanism, NASA didn't wait for full certainty before reacting. Gemini's EVA-capable hatches were a known weak point going into a program that had several more spacewalks scheduled, and the agency began tightening ground procedures for testing hatch mechanisms specifically under vacuum conditions that better simulated what the gears would face on orbit, not just the sea-level checks that had passed before Gemini 4 flew. Crew training incorporated more explicit contingency drilling for hatch problems, and later Gemini missions carried the lesson forward directly. Several subsequent EVAs, including the difficult spacewalk on Gemini 9 the following year, ran into their own hatch and mobility problems, which meant the concern raised by White and McDivitt's fight to reseal their capsule wasn't an isolated scare. It was an early signal of a hardware category NASA had to keep managing all the way through the program. The human side of the story got less attention than the spacewalk footage did, and that's partly because McDivitt and White chose to underplay it publicly. Post-flight, the crew described the hatch difficulty factually, without theatrics, consistent with how NASA generally managed public messaging around near-miss moments during an era when confidence in the space program mattered as much as the engineering itself. Internally, though, the episode carried weight. It was one of the clearer early demonstrations that a spacecraft system tested and proven on the ground could behave differently once exposed to actual orbital vacuum, and that the margin between a triumphant first for the country and a fatal re-entry could come down to a set of gears catching a locking pin on one more try. Ed White would fly again less than 2 years later, this time on the ground, inside the cabin of Apollo 1 during a launch pad test in January 1967. A fire broke out in that all-oxygen environment, and White, along with Gus Grissom and Roger Chaffee, died before they could get their hatch open. A different hatch, a different failure mode entirely, on a spacecraft where escaping quickly rather than sealing shut was the problem. It's a grim symmetry that hatch mechanisms bracket both the highest and lowest points of his short career, and NASA's response to Apollo 1 included a wholesale redesign of that vehicle's hatch to open faster and more reliably, drawing in part on lessons about crew safety margins that Gemini's program, including the Gemini 4 incident, had already started teaching the agency. What Gemini 4's hatch problem actually changed was procedural rather than dramatic. Tighter vacuum testing standards for mechanical systems that had to cycle in space, more explicit contingency training for EVA crews, and a documented, agency-wide awareness that ground-tested hardware needed to earn trust again once it left the atmosphere. No public announcement framed it as a near disaster because on paper the mission had succeeded completely. But the astronauts who lived through those minutes of a stuck ratchet, high above the Earth with no way to call for help, understood exactly how close routine and catastrophe had come to trading places. If you want more of these moments where a single mechanical detail decided whether a mission became history or tragedy, subscribe and tell me which Gemini mission's near miss you want covered next.